Another way to solve equations that are quadratics is by using the quadratic formula. This is kind of the last resort for some people because it can take a while. Other people really like this method. The nice thing about the quadratic formula is that it'll always work. Some of the methods like setting it equal to 0 and factoring doesn't always work. Or the square root method. It's great, but it doesn't always work. We've seen we can force it to work, but it can get kind of messy. The quadratic formula is kind of the standard go-to if you just want one technique that's going to work pretty well for most things. In order to use the quadratic formula, you have to have it written in standard form, just like if you were going to try and factor it. Once you have it written in this form, you're going to pull the numbers in front of your x squared, the number in front of your x, and the constant a, b, and c, and put them in the quadratic formula where they go. This is one of those guys you're just going to have to memorize. Let's take a look at example 1. First off, it's in the right format. It's already in standard form. We don't have to move anything around. I think I'm going to just take a second and decide what's a, b, and c. So a is always the number in front of your x squared. For this case, it's 1. Now, unlike completing the square where it has to be 1, here a can be anything. It doesn't matter. B is 3, and c is 1. So we are going to take those values, 1, 3, and 1, and put them in the quadratic formula. So x is going to be equal to negative b. So my b is 3. When I put it in, I'm going to get negative 3 for that first bit. Plus or minus the square root of b squared minus 4 times my 1, that's my a, and my c, which is also 1, all over 2 times a, which is 1. Personally, for me at this point, I like to take whatever's under the root and just kind of simplify it up here. It saves me from rewriting everything. 3 to the second power is 9. 4 times 1 is going to be 4. So I can see under the radical I have 9 minus 4, or 5. So let's rewrite that. Under the radical we really have a 5, and 2 times 1 on the bottom is just 2. So at this point, you're kind of done unless there's like some simplifying and reducing to be done. For example, the square root of 5. Could we simplify or reduce that? Well, in this case, no. If he was a negative 5, we'd have to pull an I out. If he was 25, we would have to do the square root of 25. So there's things that could come up here. It's just this problem doesn't have them. The other thing you're going to look for is, can you reduce? So sometimes there'll be maybe a GCF that we could pull out and reduce with a GCF. But I don't think we can do that here either. So I think this guy is done. Let's do one more of these. Now this one has some work to be done in the beginning. We do not have it in standard form. Since my x squared is positive, I think I'm going to leave him there and bring everybody to him. So I'm going to minus this 2x to the other side. And I'm going to minus this 10 over to this side. These are all going to cancel out and give me 0 over there, which is what I want. And on the left, we're going to have 2x squared plus 5x minus 4 when I combine those like terms. Is that equal to 0? So we're good to go for the quadratic formula. You can stop and take a second and decide what a, b, and c are if that helps you out. A, the number in front of your x squared, that's a 2. B, the coefficient for your x, that's 5. And c is the constant without an x. Now be careful, he's a negative 4, so watch out. Anytime you get negatives in there, there can be a little bit of a trick to it, so be careful. All right, let's put in our 2, 5, and negative 4 in the quadratic formula. So we're going to have x equals negative b, or opposite of b. So my b is 5. When I put it in, it's going to be negative 5, plus or minus the square root of b squared. So my b is 5 minus 4 times your a, which is 2, times your c, which is negative 4. Watch out for that negative. All over 2a, which my a is going to be 2. All right, let's look under the radical. When I square the 5, I'm going to get 25. When I multiply over here, think about this for just a second. If we have a negative and a negative, it's going to change it into a positive. So this is now plus. 4 times 2 would be 8, times 4 is 32. Okay, let's see. Putting all that under the radical together, we've got 25 plus 32, which is going to be 57, all over 4. And before we say we're done, we're going to look at this and decide, can I simplify some more here? The square root of 57, can we reduce or simplify that? Can we pull a perfect square out of here? I don't think so. So I think that bit's done. Can you reduce? Is there a GCF that you could pull out and reduce with the 4? Nope, I don't think so. So this guy is all done. It's important to understand we still have 2 answers here. We haven't talked about that too much, but remember you could write this as negative 5 plus root 57 all over 4 and negative 5 minus root 57 all over 4. Those are the same answers because remember that plus or minus means you have the positive and the negative version.